Hi everyone. So I want to talk about the quiz a little bit. So first of all, I am sorry for this typo. This should read Z was the name of the map that went from the natural numbers to C. Which sort of means usually we would say, okay, then a little number n becomes some complex number Z sub n. Okay, so this was a typo. This doesn't make any sense. Sorry about that. Okay, so when is a sequence bounded? When there exists some number that's positive, because it's going to be the radius of a ball, such that for all natural numbers, z sub n, the size of it is less than b. That just means that it's in a ball about the origin. Okay, this is radius b, and all the z sub n are in there, okay, for all n. So there exists a b such that for all n, this is true. Okay, so when it's bounded. Okay, so unbounded, bounded, 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 unbounded, bounded, because these are just digits. They never have 10, and they can't be 10. It's just the digits. It can only be 9 or less. Okay, so then this one, first of all, the limit is equal to 1. Okay, and now how do we prove this? So first we do some scratch work. We know that we need to show that for all possible positive numbers, there exists some, and actually one of you actually made me realize that this could be a real number, I suppose. I usually think of it as an index of the sequence, but think about it, and it works either way. There exists some capital N such that for all the n greater or equal to capital N, or another way to say this is that, n greater than or equal to capital N implies that the Zn are within D of the limit, which is this number, okay? And this thing is Z sub n. Okay. So we need to find this capital N, and it's gotta depend on D. Okay, so now the scratch work we do is we think, what is this gonna mean in our sequence? Well, n minus 1 over n plus 1 is this number. So first of all, before I just start filling up with junk, I'm gonna go down here and think about, okay, what is this expression? Well, it's equal to n minus 1 over n plus 1 minus 1, which is equal to n minus 1 over n plus 1, n plus 1 over n plus 1, subtracting, and that is going to be n minus 1 minus n minus 1 over n plus 1, absolute value, which is negative 2 over n plus 1, absolute value. Now the absolute value of this, remember, little n is just a natural number, so it's not negative, it's a positive number. So the only thing that happens is the negative 2 becomes a 2. Okay? So this number here is in fact equal to this number. So that means, if we choose, if n is bigger than, okay, so let's choose. Remember, we want this one to be less than D, but this number is equal to that one number. So can we make this less than D? Well, yes, we can. So choose n greater than, no. Choose n such that 2 over n plus 1 is less than D. Now, why does this work? So then little n greater than capital N implies that 2 over little n plus 1 is less than 2 over capital N plus 1. Why is that? Because if little n is bigger, we're farther out in the sequence, then this is a bigger number than this, which means this is a smaller number. So if the denominator is bigger, then the entire fraction is smaller. Okay, and now we come back up here. So choose, so for any d, choose n so that, what was it, 2 over n plus 1 is less than d. Okay, we can do that by making this denominator big enough. It's clear. If you want, you could do some more algebra there, but choose capital N so that this is less than d. Then n greater than n implies Zn minus 1, which is equal to 2 over little n plus 1, which is less than 2 over big N plus 1. And right here is where I'm using the fact that n is past capital N. And that is less than d, as needed. End of proof. Okay. Now, for this equal sign here, I would say see calculations below. Okay, and that's pretty much it. So you do need these calculations right here, because they tell you how to choose n. Okay. So this was my solution. So for any d, choose capital N so that this number is less than d. You can do that. If you want, you could give more of an argument that that's possible, but I think it's pretty clear that it's possible. If you divide 2 by a really big number, it'll be smaller than any positive number. Okay. So, yeah. So your reader is basically, you're hoping that your reader understands that this is true without you needing to go into more detail here. But this part, you want to actually show to your reader right there. There's the calculations. And then this part is because you're farther out in the sequence. And this is what we wanted. Well, really, this being less than this is what we wanted, right? Because that is the definition of convergence. Here's the definition of convergence. And here is using the definition in a proof that the sequence converges. Okay. Okay, but I mean, you don't need to label that part. I can get rid of that. This is a complete answer, including this part. Okay. Excellent.